Okay, for this next tutorial, I'm going to show you how to do a simple bivariate correlation, computing Pearson's Product Moment R. In class, I had you complete a Google document, a survey in Google Doc, asking you how many hours a week you study and how many hours a week you exercise. I showed you in a previous tutorial how to convert that document into an SPSS file. So what you're looking at here is the final cleaned up version of that SPSS file. Before we do the Pearson's correlation, it's important to realize that the two variables I'm going to correlate, in this case study and exercise, both need to be measured on an interval ratio scale. In this case, they both are. So to do the Pearson correlation, I simply go to Analyze, Correlate, Bivariate. Click on bivariate, and you see that I've moved my two variables over, study and exercise, into the variables list, and I want to do a Pearson correlation. You recall from our class discussion that there are ways to do Spearman correlation for ordinal data, Kendall's tau for nominal data. My significance test is going to be two-tailed. I'm not going to specify a direction in my hypothesis. I'm just going to say that studying, number of hours studying and number of hours exercising will be related. SPSS will flag significant correlations for me at the 0.05 level, and I'm going to ask it to give me means and standard deviations so that I can include that in my report. I'm going to click OK, and I'm going to look at my output, and what I see here is the first box is descriptive statistics. It tells me the mean for exercising was 6.658. Studying, the mean for exercising was 3.5. Now the question is, do changes we observe in studying, in other words from 0 all the way up to 15 or more hours, explain changes we observe in exercise on that same scale? And we had 26 of you who completed the survey. So my correlation table tells me that the relationship between exercise, number of hours exercising, and number of hours studying is negative 0.066. The negative tells me that the correlation is negative, meaning as we observe increases in one variable, we observe decreases in the other variable. The actual value, 0.066, tells me that we have a very small, negligible correlation. In fact, it's approaching 0, which means the two variables are almost perfectly not correlated. They are not flagged, which means that this is not significant. In fact, the actual p-value is 0.749. And remember, we need a p-value of under 0.05 for it to be significant. If these two variables were significant, I would have seen this value right here be less than 0.05. So there is no relationship between exercise and number of hours studying based on how we've measured it and within our sample.